All right, let's take a look at today's lesson. So what we're looking at today is areas and piecewise functions. So we looked at area yesterday, and we talked about how in calculus, area under the curve is a really big topic. It's a really important topic. And yesterday we learned how to estimate the area under the curve, using little rectangles, Riemann sums. Today we're going to actually be able to find the area under the curve, because these are geometric shapes. We're going to be using triangles and circles and stuff like that. So both of these kinds of things you will have next year in calculus. They're both concepts that we look at. So let's start with this first one. On this first example, we're going to view this graph f of x as the position. This is the position graph, and they typically write this for us. These are lines in a quarter circle, just so that we're clear. This isn't some kind of a parabola. It's actually a quarter circle. All right, so this is what we're going to be dealing with on this slide. The first thing they want us to do is write an equation for the function p of f of x, and it's going to be a piecewise, right, because we have a bunch of little pieces that we would need to calculate. So I'm going to actually write the piecewise function up here, just because I have a little bit more room. Doesn't really matter whether you start writing from the smallest part to the largest or largest to smallest. Doesn't really matter. For whatever reason, I started over here. I started on this line. And there's several ways I could find the equation of the line. We've been doing this for quite some time. So one way I could do slope, so rise 1, run 1, so my slope is a -1, right? And I could do, my favorite equation of the line, I could do point slope, which is y minus y1 equals m times x minus x1. My slope is a -1. I could use this point. That's kind of easy. What is that? 1, 2, 3. That's 4, 0. So I could do y minus 0 equals -1 times x minus 4. I'm solving for y, and I get -x plus 4. Of course, you don't have to show any of this work. You can do it in your head if you want to. You actually could kind of, extend this up to find the y-intercepts like that. There's just a lot of ways you could find that equation. This is just one. So we're going to put the equation here, and it's good from what? 1, 2, 3, from 3 to 6. Now you can write it in interval notation if you like, the 3 to 6, or you can put it in, inequality. Usually they're an inequality, but I'm okay if you write it as an interval. So -3 less than equal to x less than 6. So I typically will we want to put the equal to with one or the other numbers, or actually in this case we could put it with both, but the rest of them just pick one of the other numbers. Since I chose -3, I'm not going to be able to pick that one again, right? Then it wouldn't be a function. So the next piece is this piece right here. In fact, just a little aside, I didn't have to write this as two separate lines. I don't know if you can see, but I could have written this as an inequality, right? This is as an absolute value. I could have written this as an absolute value. I just didn't choose to. It's up to you. You don't have to unless it's asked you to write it as an absolute value. But I'm just going to write it as two separate lines. So we're probably okay with the lines. Can I just go ahead and write them down? We know how to do that. So the next line would be x minus 2, and that's going to be good between 2 and 3. Oh, this is a positive. Between 2 and 3, so 2 less than equal to x less than 3. Then this part right here is a quarter circle. Now that one's a little bit more challenging, but it's not too bad. Let's kind of walk through how would we find this equation to this quarter circle. Let's kind of envision what it would look like if it were a full circle. It would just come up and come around, right? My center of the circle would be at 0, 0. So that is an x squared plus y squared thing, right, with the center at 0, 0. My radius is 2. So x squared plus y squared equals r squared, right? So 2 squared would be 4. Now that would give me my equation. I can't really write it like that over here because this is like y. F of x is y. It's like a y equal thing. So I really have to solve this for y. So I would have y squared equals 4 minus x squared, and y is plus or minus square root of 4 minus x squared. Now let's talk about the whole plus minus thing. It's something that we encounter in calculus all over the place, and we just want to make sure we're clear what's going on. How do I know which piece I want to use? Well, if y, so we're focusing on y and the signs, right? If y is positive, that's up here. Right? So if my circle appeared up there, I would use the plus radical, right? If y is negative, on the other hand, so let's say we're looking at this part down here, underneath the y's are negative down here, right? So if my circle was down here, or my part of circle was down here, I would want to use the negative version. All right, so that's okay, right? We get that. So since this little quarter circle falls underneath the x-axis, we're going to need to use the negative version of our equation, which would be negative square root of 4 minus x squared. And that equation is good from 0 to 2. Okay, so there's our quarter circle. And then here, this is a horizontal line, right? The equation of a horizontal line is just y equals. So it's what? Negative 2, so y equals negative 2. And that's good from, what, negative 1 to 0. And then this last line looks like our slope is negative 1 again. And that is, what, negative x minus 3. And that's good from negative 3 to negative 1. Okay, so there's our equation. Are we okay with that? Just pretty straightforward. That's probably, I don't know, we may have done something like that in Algebra 2 or... Alright, that's our equation. So, got that. Alright, so let's look at number 2. Find the area from negative 1 to 4. So let me get a little bit of room up here, and let's concentrate on what that's asking. So we're looking for the area from negative 1, so from here to 4. 1, 2, 3. Now, these kinds of areas are typically associated with an integral. And so we're really not looking at an integral now. We're not talking about an integral, but they usually are. Since we don't have any reference or frame of reference like an integral, what we look at is if the area falls below the x-axis, like this part right here, the area would have a negative sign. Now, there isn't any such thing as negative area. It's just the sign of the area would be negative. Now, if you want to think of it as negative area, if that helps you, that's fine. So if we're under the x-axis, it's negative. If we're above the x-axis, it's positive. And we're always looking for the area between the curve and the x-axis. In the most simple cases like this, curve and the x-axis. There are other things we're going to do, but that's next year. So curve and x-axis. So I need this right here. So I need this space. I need the area of that part. This, and you can split it up any way you want. They're just geometric figures, however you would like to. This, I would make this like a little rectangle, and that would be negative 2, right? That would be my area for my little rectangle. Here, so that's just a quarter circle, so 1/4 pi r squared, and that's what, 2 squared. So this area is just negative pi, right? Are we okay? So it's negative because it's underneath the x-axis. And this last portion, so this is just a triangle. It's just a triangle. So half base is 2 times height. So this is just 1. So let's add it all up. So we have negative 2 is the first area, minus pi, and then plus 1. Just simplifying that, bringing it together, we get -1 minus pi. And that's our area. Okay, we okay with that? Alright, now let's look at some other things that we can do with the graph. We're looking for intervals of increase or decrease. Let's do that first. Let's not talk about concavity yet. Let's do intervals of increase, decrease. So let's clear this off again. So since this is the position, increase and decrease, we've talked about that before. Read it from left to right, just like I read a book, right? If I'm coming from left to right and it falls, then I'm decreasing. Here, it's not increasing or decreasing, right? It's flat. And then I'm increasing and decreasing. Okay? So let's kind of list all those things. So increase, and let's go ahead and write it a little bit higher so we can see it better. So increase, let's see, that's not, so here I'm increasing right here between 0 and 3. So increase between 0 and 3. I like to use parentheses. You could use parentheses or brackets. Either are fine. Decrease, and we need to say, we're going to say why. Even when it doesn't ask us, we're going to say why. Well, here, on increase we're just reading the graph. So let's not justify yet. We're just reading the graph. This is just coming up and going down. So we're just going to leave it at increase and decrease. So decrease, we're decreasing here from what, -3 to -2, and 1, 2, 3, from 3 to 6. Now if you want to put the little U here, the little union symbol, that's perfectly fine. That's perfectly fine to do. You can do that if you want to. You can also separate them with commas. That's also perfectly fine. It's really your choice, whatever you would like to do. So that takes care of increase or decrease. Now let's talk about concavity. I think we have talked about concavity before. I don't remember. Do we remember talking about concavity? So concavity, this is a concept that we're working on. The first thing that I want to say, that make sure we're clear, is lines have no concavity. None. And I'm going to write that down. Lines have no concavity. Concavity is curvature. Lines don't have any curves. Right? So let's talk about concavity. If it curved up, that's called concave up. If it's curved down, that's called concave down. I mean, that's how it works, right? Curved up, curved down, concave down. And we just said that lines have no concavity. So when we're answering this question, what interval is concave up or down, we aren't even going to look at lines, right? The lines have no concavity. There's nothing to look at. Nothing. The only thing we look at for concavity are curves. And there's a curve right there. And is that concave up or concave down? It's concave up, isn't it? Think about it as a cup if you want to. Like, is the cup regular turned up or is the cup upside down? If that helps you on determining. So we would say that it's concave up from 0 to 2. Okay. The last one on this page talks about absolute minimum and absolute maximum values. Alright, so this is another really big deal. Oh, we're getting to do so many fun calculus things. So exciting. Okay, so absolute extrema, absolute mins and absolute maxes is the so first of all, let's talk about what a minimum and maximum value are. It's the y value. Okay, the y value is the big deal. Poor little y values really don't get a lot of, you know, I don't know, when we are solving equations, we're finding x's, we're not finding y's, right? So y's don't get a lot of attention. So maybe that's why many students answer this question incorrectly. Why? I don't want to know where the maximum or minimum value is. I want to know what it is. right? I can't tell you how many errors we get because we're so focused on where it is, what x value it occurs at, that we don't even say the poor true what the minimum value is. It's a y value. All right, and this doesn't ask where it is at all. We don't even have to say where it is. It doesn't matter. It wants to know what is it. What is the absolute minimum value and the absolute maximum value? So, an absolute minimum doesn't mean the absolute value. Okay, it's a different use of the word. Absolute minimum means the very smallest number, the very smallest y value. In this particular case, our very smallest y value in this picture is -2. Now, it occurs a lot of different places, right? I have -2 all along here, but it doesn't ask where, so it doesn't matter. We don't have to write anything. It just asks what is it. Our absolute maximum value, so we just look on the graph. What's the very tallest part of the graph? Well, that's at 1, right? That's the very tallest y value. So our absolute max is 1. And that's what it wants to know. It doesn't. It doesn't have anything to do with absolute value at all. That's a good question, and that's have been a confusion today. Yeah, it has nothing to do with absolute value at all. It's a different word of the different use of the word absolute. It simply means absolute in that it is the very biggest, or it is the very smallest. All right, then this, are we good okay so far? Okay, so we have one more slide. And on this last slide, we're going to use the same picture, but we're going to look at it in a different light. We're using the same picture, but now we're going to use this as velocity. Okay, so we're going to use this picture as velocity. So we're going to read it differently. We're going to read it differently than we would a position. So when does the object stop? Now, probably most of you have had physics or are in physics, probably, or will take physics, one or the other. You're in one of those groups, right? Maybe you already know about velocity. We know that when does an object stop? That's when velocity equals 0, right? Then when 0 means it's not moving. So we need to look at this picture and find out where the y values, because this is velocity. This is a picture of velocity. It's a picture. So we want to know where the y values of this picture are 0, right? That's when it stops. So the y values are 0 here and here and here. So when does the object stop? And this is using the variable x. They're saying it's x-axis, so we can use x's. A lot of times it's t, but that's fine. So it stops at x equals -3, at x equals 2, and at x equals 4. And our justification is because v equals 0. I mean, that's really all you have to do to justify it, because v equals 0. If you don't want to say that, you could write it out in words, because velocity is 0, but you don't have to. I mean, it's perfectly acceptable to write it just like that. All right, so moving left and right, when we're in a circumstance like this, you know, when we're moving along the x-axis, left and right have to do with the velocity being negative. That means we're going left, and the velocity positive means we're going right. Right? And so I'm looking for, again, y values. That's where I'm making my decision on y values. So I want to know, when are my velocity y values negative? That means left, right? Left is when velocity y values are negative. That's when the graph falls under the x-axis. So that's going to be from what, -3 to 2, and so from 4 to 6. Now at -3, 2, and 4, those actual velocity values are 0, right? But what about with 6? Isn't that actual value negative? Right? Shouldn't I include 6 in being part of the left movement? Right? Because it actually still is negative. The others are 0, so we don't include that, but we would include this one, right? Okay, so now, and we would say because v is less than 0. What an easy justification. How hard is that, right? Because velocity is less than 0. Great. So we're moving right when we're above the x-axis. We're above the x-axis from 2 to 4, and that's because velocity is greater than 0. Okay, those are our justifications. Okay, how are we with that? Is everybody okay?